Hello students. From the past two lectures, we know that trigonometric equations can have two types of solutions. We have already discussed the principal solution of a trigonometric equation. It is a solution that lies between 0 and 2 pi. Here we discuss the general solution of a trigonometric equation. The definition: the solution of a trigonometric equation which is generalized by using its periodicity is called as its general solution. Remember, trigonometric equations are periodic in nature. The solutions are periodic in nature because they keep repeating themselves. For example, the solutions of the equation sine theta is equal to half. Now we know that sine 30 is half. That means one answer we already know, that is pi by 6. Besides pi by 6, it can have an infinite number of solutions of the form minus 7 pi by 6, 5 pi by 6, 13 pi by 6 and so on and so forth. The number of solutions are just infinite. We are going to discuss how to find the general solution of a trigonometric equation in this particular lecture. We first discuss certain theorems to understand more about the general solutions. The moment you hear the word theorem, the common response is to get afraid. Just remember, students, that theorems actually help us understand how a particular concept came about in the first place. And so, when we understand that concept, we remember it in a better manner. This is much better than learning formulas and shortcuts and all that. Learning the concept is much better at keeping in mind. It remains in the mind for a longer time. So the first theorem, the general solution of sine theta is equal to sine alpha is theta is equal to n pi plus minus 1 raised to n alpha, where n is any integer. N belongs to z. Z is a general set of integers here. So n is any integer. Now just concentrate on the explanation. I am sure that at the end you will understand the theorem and you will know the formula also. Say they have given us sine theta is equal to sine alpha. So surely we can say that alpha is a solution of the particular equation. Now just ask this question in your mind as to in which quadrant is sine positive. Now I'll help you with the standard unit circle. As you can see in the figure, sine is positive in the first and the second quadrant. First quadrant, of course, all are positive, as well as in the second quadrant we have sine theta as positive. You already know how to find out which trigonometric function has what sign and in which quadrant. That I'm not going to go through it in this particular lecture at least. So we find that in the second quadrant, that is when the angle becomes pi minus alpha, sine is positive in that particular quadrant. So we can write sine pi minus alpha is equal to sine alpha. Thus, we say that pi minus alpha is also a solution. So same like sine theta is equal to sine alpha, we have sine theta is equal to sine pi minus alpha. Now using periodicity. What is periodicity? It is an interval at which the trigonometric function repeats itself. Now the period for a sine function is 2 pi. 2 pi means whenever the function completes, whenever the angle completes a full circle, we start with an angle in the first quadrant, say, we go in the anti-clockwise direction. And when we come a full circle, that is when we complete a distance of 2 pi, the angle repeats itself. The same value comes once again. So the period of sine is 2 pi and therefore we can write sine theta is equal to sine alpha. From the first statement, sine theta is equal to sine alpha is equal to, when we complete a period, that is when we complete a distance of 2 pi, it becomes sine 2 pi plus alpha is equal to, once again when we complete the circle, it becomes 2 pi plus 2 pi plus alpha. And once again when we complete one more circle, the third time or the fourth time rather, it becomes 2 pi plus 2 pi plus 2 pi plus alpha. And so on and so forth. We can just go on and on and on. Thus from this we get sine theta, that is from here 2 pi plus 2 pi plus alpha. We get sine theta is equal to sine alpha, which is equal to sine 2 pi plus alpha is equal to, now we are adding that 2 pi plus 2 pi. As you can see, I have pointed it out to you, is equal to sine 4 pi plus alpha, which is equal to sine 6 pi plus alpha is equal to sine 8 pi plus alpha is equal to sine 10 pi plus alpha is equal to sine any even number pi plus alpha. So in this way, it goes on and on. 1 as you saw. Similarly, from sine theta is equal to sine pi minus alpha by periodicity, as you can see the angles repeat after every 2 pi interval. We get the two statements as equal to sine 2 pi plus pi minus alpha, sine 2 pi plus 2 pi plus pi minus alpha, and so on. Thus we get sine theta is equal to sine pi minus alpha is equal to sine 3 pi minus alpha, which is equal to sine 5 pi minus alpha, and so on. Removing sine from both the sides in statement 1, we get theta is equal to alpha 2 pi plus alpha, 4 pi plus alpha, 6 pi plus alpha, or any even multiple of pi plus alpha. And from statement 2, we get theta is equal to pi minus alpha, 3 pi minus alpha, 5 pi minus alpha, any odd multiple of pi minus alpha, and so on. Thus, combining 1 and 2, the values of theta in 1 and 2, we get theta is equal to alpha, pi minus alpha, 2 pi plus alpha, 3 pi minus alpha, 4 pi plus alpha, and so on. Now you see a particular pattern emerging over here, isn't it? Whenever pi has an odd multiple, it is minus alpha in the answer, thus pi minus alpha or 3 pi minus alpha or 5 pi minus alpha, etc. And whenever pi is an even multiple, that is whenever pi is multiplied by 0, 2, 4, 6, etc. the answer is plus alpha. The answer has plus alpha. So we have alpha when pi is multiplied by 0. When pi is multiplied by 2, we get 2 pi plus alpha, 4 pi plus alpha, 6 pi plus alpha, etc. This has been generalized into a formula. Thus this formula, that is the general solution of sine theta is equal to sine alpha, is theta is equal to n pi plus minus 1 raised to n alpha, where n is any integer. For example, when n is odd, when n is an odd number, for example 3 is an odd number, so when n is 3, putting n is equal to 3 in the formula, we get theta is equal to 3 pi, that is n pi, instead of n pi, 3 pi. So 3 pi plus minus 1 raised to 3 alpha. Now minus 1 raised to 3 is minus 1 into minus 1 into minus 1, which is minus 1. Thus the answer comes as 3 pi minus alpha. So any odd multiple of pi minus alpha. Similarly, when n is even, we get, for example, if n is 4, we get theta is equal to 4 pi plus minus 1 raised to 4. Now into alpha. Now minus 1 raised to 4 is 1. Thus we get 4 pi plus alpha. That means any even multiple of pi plus alpha. Thus we are working out the general solution. Next we go on to prove the general solution for cos function. The theorem is the general solution of cos theta is equal to cos alpha is theta is equal to 2n pi plus or minus alpha, where n is any integer. Again, if you understood the previous theorem, this theorem should prove to be easy for you. Now, already as usual, cos theta is equal to cos alpha. So alpha is anyway a solution of the particular equation that is there. Now, we also know that cos of any negative angle is same as positive cos. That means cos of minus alpha is equal to cos alpha. So we say that minus alpha is also a solution. Thus, cos theta is equal to cos alpha, or cos theta is equal to cos minus alpha. Now using periodicity. Again, the period of cos is 2 pi, which means cos functions repeat themselves after every 2 pi interval. Every time we complete a full circle, the value of cos is same as the value that we started with actually. So we get cos theta is equal to cos alpha, which is cos 2 pi plus alpha, which is cos 4 pi plus alpha, cos 6 pi plus alpha, and so on. And similarly, from cos theta is equal to cos minus alpha, we get it as equal to cos 2 pi minus alpha, as cos 4 pi minus alpha, and 6 pi minus alpha, etc. So each time we complete a circle, the cos values are repeating themselves, as you can see. Now from the first statement, removing the cos from both the sides, we get theta is equal to alpha, 2 pi plus alpha, 4 pi plus alpha, 6 pi plus alpha, and generalizing any even number even multiple of pi plus alpha, which is 2n pi plus alpha. Similarly, from 2 we get theta is equal to alpha, 2 pi minus alpha, 4 pi minus alpha, 6 pi minus alpha, or as we go on and on, you can just generalize it as any even multiple of pi minus alpha. That means the general solution of cos theta is equal to cos alpha is equal to, now we are combining both the values of theta and generalizing it. Theta is equal to 2n pi plus or minus alpha, where n is any integer. Just concentrate, just pause the video, concentrate on the theorems and try to understand them thoroughly. Theorem 3, that is the general solution of tan theta is equal to tan alpha is theta is equal to n pi plus alpha, where n is any integer. Here we use the formula for tan, that is tan is equal to sine upon cos. So tan theta is equal to tan alpha can also be written as sine theta upon cos theta is equal to sine alpha upon cos alpha. Cross multiplying, sine theta cos alpha is equal to cos theta sine alpha. Taking everything on one side, we get sine theta cos alpha minus cos theta sine alpha is equal to 0 on the RHS. Using the formula sin A cos B minus cos A sin B is equal to sin A minus B, the previous statement becomes sin theta minus alpha is equal to 0. Now sin 0 is 0. So we can also write RHS as sin 0. We know that a general solution of sin is sin theta is equal to sin alpha is theta is equal to n pi plus minus 1 raised to n alpha, where n is any integer. So applying this general solution in the previous statement, on the RHS we put alpha as 0. We get theta minus alpha is equal to n pi plus minus 1 raised to n 0 into 0. Instead of alpha we have put 0 only on the RHS for the sake of proving the statement that is there. Thus we get theta minus alpha is equal to n pi, because anything into 0 is 0. Taking alpha on the RHS, we get theta is equal to n pi plus alpha. Thus, we say that the general solution of tan theta is equal to tan alpha is theta is equal to n pi plus alpha, where n is any integer. These are the three main theorems. Of course, you are going to apply them in sums. But in the exam, sometimes they also ask you to prove these theorems. So be thorough with the statement and be thorough with the proof as well. The next theorem, the general solution of sin square theta is equal to sin square alpha is given as theta is equal to n pi plus or minus alpha, where n is any integer. Now here sin square theta is equal to sin square alpha. It is already given to us. Converting this into the double angle formula, we can write instead of sin square x, 1 minus cos 2x upon 2. So sin square theta becomes 1 minus cos 2 theta upon 2, and sin square alpha can be written as 1 minus cos 2 or alpha upon 2. Cancelling out the common portions, we get cos 2 theta is equal to cos 2 alpha. Now using the general solution for cos, that is cos theta is equal to cos alpha means theta is equal to 2n pi plus or minus alpha. We get 2 theta is equal to 2n pi plus or minus 2 alpha. Cancelling 2 from both the sides, we get theta is equal to n pi plus or minus alpha, where n is any integer. Thus, the general solution of sin square theta is equal to sin square alpha is theta is equal to n pi plus or minus alpha, where n is any integer. The next theorem, that is the general solution of cos square theta is equal to cos square alpha is theta is equal to n pi plus or minus alpha, and similarly the next to next theorem, that is tan square theta is equal to tan square alpha is theta is equal to n pi plus or minus alpha. That is the general solution there. In both the cases, n is any integer. Now these two theorems I believe are easy enough for you to understand, and so I leave it to you as an assignment to read and get the theorems. Wherever a difficulty arises, You can always contact me through WhatsApp. Now these are a few more results which we may use in our sums to follow. Remember, trigonometry is difficult only in the mind. Once we start understanding these concepts, they automatically become interesting to us, and we will wish to solve more and more problems of these types. In the next lecture, we start with solving the problems based on the general solutions. That is, we use all these theorems and start solving sums. So see you in the next lecture, students.